We're going to talk about the chain rule. The chain rule is a rule of differentiation that allows us to differentiate the composite of two functions. So by composite, we mean the situation where we replace the variable of one function with the formula of another. So something like f of g of x. So to show how this works, let's say that we have f of x to be 2 to the x and g of x equal to x cubed. Then f of g of x, what we need to do is replace x in 2 to the x by x cubed, is going to be 2 to the x cubed. And so far we have not developed any way of knowing what the derivative of such a function is. And that's exactly what the chain rule tells us. It would be a good idea to actually introduce some terminology. So let's call the function that gets plugged in the inner function. And the function in which we plug in, let's call it the outer function. As we're going to see, we're going to develop a method where we will just want to find, to identify the inner function and then work our way from there. But let's first of all give the formula. So formally speaking, the chain rule is given by this formula. So the derivative of f of g of x is the following. So we start with a composite where the outer function is f prime, the derivative of f, and the inner function is g of x, just simply the original inner function. And then we multiply by the derivative of the inner function. So let's see how that would work for the example that we gave above, this example. So in other words, the derivative of f of x would be 2 to the x ln 2, and the derivative of g of x would be 3x squared. That's what we need to know. So then we can ask, what is f prime of g of x times g prime of x? And the answer would be, well, you need to take x cubed, which is g of x, and plug it in right here. So that would give you 2 to the x cubed times ln 2. And then you need to multiply by the derivative of the inner function, the derivative of g of x, g prime of x, which is 3x squared. And that's what we get. And this is the formal way of doing this. So you have to identify the outer function, the inner function, find the two derivatives, and apply this formula. But we're going to simplify the process by arguing as follows. So let's see how we're going to do it. If somebody gives us the composite of two functions, then all we need to do is, first of all, identify the inner function. And in this case, we say that the inner function is x cubed. So if we wish to find the derivative of this, what we do is the following. We think of x cubed as another variable, let's say y. Okay, and let's see what mentally we would do here. So let me put it in a parenthesis. So we would ask ourselves, if we had 2 to the y, and y was a regular variable, then what would be the derivative of 2 to the y? And of course, the answer is 2 to the y ln 2, right? And then that's exactly what we write. But instead of ever writing y, we just write the inner function, meaning we write 2 to the x cubed times ln 2. And then we multiply by the derivative of what we designated as the inner function. In this case, the derivative of x cubed, which is 3x squared. Okay, let's see it with another example. Let's see how this works. So let's say that we wanted to find the derivative of sine of square root of x. Then we start by designating our inner function, which in this case, it shouldn't be too hard to identify. Sine of square root of x square root of x would be the inner function. So we think of this as sine of y. And we ask ourselves, what is the derivative of sine of y? And the answer is cosine y. We never write actually y, so we write cosine of what we designated as y, which is square root of x. And then we multiply by the derivative of what we had designated as y. So the derivative of square root of x, which is 1 over 2 square root of x. Let's do another example. So, and actually for each of the examples, it's a good idea to pause the recording and try to do it yourselves. So let's say that we had e to the tangent x. Okay, we want to find this derivative. How do we find this derivative? So we think of tangent x as y, and we ask ourselves, what is the derivative of e to the y? And the answer is e to the y. So we write e, we never write y, we write e to the tangent x because that's what we designated as y. And we multiply by the derivative of tangent x. So that's secant square of x. Let's do another one. So let's say that we have the derivative of x squared plus x plus 1. Let's designate our inner function. Our inner function is going to be x squared plus x plus 1. So we're looking at square root of y. What is the derivative of square root of y? The answer is 1 over 2 square root of y. So we write 1 over 2. We never write y. We write x squared plus x plus 1. And then we proceed to multiply by the derivative of what we designated as y, which is 2x plus 1. Let's do 3 to the secant x. Again, pause the video and try to do this yourselves. So let's designate our y. What is our y? Secant x, the inner function. So what is the derivative of 3 to the y? It's 3 to the y ln 3. So let's write that. Again, we never write y. We write 3 to the secant x times ln 3. And then we multiply by the derivative of what we designated as secant x, which is tangent x secant x. Let's do the derivative of cosine to the 7th of x. Now, here it might be useful to do an intermediate step. Let's recall that cosine to the 7th of x is the same thing. Let's write it in a more traditional way, cosine of x all to the 7th power. So let's designate our y. Our y here is cosine x. So we're looking at the derivative of y to the 7th. What is the derivative of y to the 7th? 7y to the 6th. So we write 7, not y, but rather cosine x to the 6th power. And then we multiply this by the derivative of cosine, which is negative sine x. So this would be 7 to the cosine to the 6th of x times negative sine x. And let's do another one. 5 to the square root of x. Let's designate our function, our inner function, that would be square root of x. So let's, so we're looking at 5 to the y. What is the derivative of 5 to the y? 5 to the y times ln 5. So 5 to the square root of x times ln 5. And then we have to multiply by the derivative of square root of x, which is 1 over 2 square root of x. Let's do one more. What is the derivative of secant of 3 to the x? This is a little more interesting. So again, our inner function is 3 to the x. We think of 3 to the x as y, so we're looking at secant of y. And what is the derivative of secant of y? The derivative of secant of y is tangent of y times secant of y. So this is why I said it's different. Y here occurs in two different places. So we have to write tangent of y. Again, we never write y. We write 3 to the x. times secant of 3 to the x, and then we multiply this by the derivative of what we designated as y, which is 3 to the x ln 3. And that's it. Thanks for watching.